Hi, welcome to this course. Myself Muhammad Yaqub, I am the founder of ScratchLearn. In this project, we are going to learn about AI-based PPE detection. What is mean by PPE? It's a personal protective equipment. So in many industries, for workplace safety and compliance, PPE is the very essential part. In many scenarios, the chief security officer and managers will be taking over of this kind of responsibility manually. So what we are going to do is that we are going to utilize cameras, and then we are going to detect the PPE like in real time with the help of AI. So for example, in any industry, wearing the safety helmet, wearing the safety mask, wearing the gloves, wearing the safety shoes, which will be essential, that has to be followed in the industry. That falls under the safety compliance. If there's any security audit, if anyone is not following the PPE rules, then that will be a major penalty for them. So to make sure that, like for example, if you take food industry, the gloves is very important, hand cap is very important, and then if you take any kind of chemical industry, face mask is very important. If you take any kind of construction kind of manufacturing industry, then safety helmet, safety shoe is very important. So each industry, different kind of PPE rules are followed. So to make sure all the complaints are followed regularly in their industry, we have developed tailor-made solution for PPE detection. So in this project, we are going to use data sets which is collected across different PPE scenarios, and then we are used YOLOv8 architecture to custom train the PPE model, and then we are doing the inference and finding out if anybody is not following the any kind of PPE rules, it will give the alerts. And then we have used Flask framework as a front end, and then we used SQL for storing the database. And this is the total overview of the project.
Programming language to implement our entire project. For that, we need to install a Python IDE. We are going to use only a specific version of Python for implementing our entire project. For that, we need to install Python 3.12. And if you have already installed any other version of Python on your machine, then it must be uninstalled from your machine. So let's see how to install Python on your machine. First, you need to go to Google and type in Python 3.12 py release. Then scroll down. Select the Windows installer 64-bit. Then simply click to run it. Then select Add Python to Path. Then click Install. Now Python is successfully set up on my machine. Then close it. Now we can go and check the Python version using CMD. py-hyphen version. On my system, the Python version is 3.120. Now we can go ahead and implement our project. Before implementing and executing any part of our project, first we need to install VS Code on your machine. And if you already installed VS Code on your machine, then that's perfectly fine. This guide is for those who have not yet installed VS Code on their machine. Let's go through it step by step. VS Code is a platform that makes it easy to build applications. To install VS Code on your machine, first you need to go to Google and type VS Code. Then press enter. Select Visual Studio Code from the results. Then click on download for Windows 10 and 11. Now the download has started. We need to wait a few seconds for the download to complete. Now VS Code has been successfully installed on my machine. Then I go to the folder. Then right click on the file to install. Next, accept the agreement and click next. Next. Yes. Next. Next one. Install. We need to wait a few seconds for the installer. Now VS Code has been successfully installed on my machine. Then click finish. Now we can go and check the version of VS Code using CMD. Then type CMD here. Type code version. The VS Code version is 1.953, and now we can implement the project step by step. Before we dive into the code explanation and execution of the project, I would like to explain what the project is about, what are the techniques we will be using in this project, and what other files are included. What other IDE are we going to use in this project? The project is called PPE detection. In this project, we will use the YOLOv8 model for PPE detection and classification, including categories such as person, hard hat, safety vest, and mask. These are the classes that we will detect and classify using a custom dataset, which we will collect from the Kaggle website. And we plan to train the model using 10 or 20 different approaches. Once the model training is complete, we will perform inference on the VS Code platform. I also created a small web-based Flask framework where we will provide input through the Flask-based web browser, display a video in the browser, input the path to the model, and then get a response using the NVIDIA Nim API. This is a brief overview of the project. Next, we will look at the files and folders available in the project. This is the PPE image folder, which contains up to 5 images P1, PP2, PP3, and so on, which will be used to determine whether a person is wearing any of the PPE equipment or not. And we have a PPE video folder, which contains 3 sets of videos: PPE input, video 2, video 1, and video 3. And this is the static folder, which contains an image folder that will be used as the login page background. And then there's the template folder, which is a Flask folder containing about page, base page, index page, login page, model inference, and register page. And these are the classes: hard hat, mask, person, and safety vest. This is the final inference py file. This is the pp ipnb file, which will be used for training on the Google Colab platform. This is the SQLite database, which is used to store person information. Then there's the requirements txt file, which will be used to install some necessary libraries for making inferences. This is the sort py, which contains the IOU technique and will assign a unique ID to each detected object. First, we are going to see how to train a model on Google Colab platform using Ultralytics and YOLOv8 model. Then we will make inferences using the trained model. For that, first you need to go to Google, then type Google Colab here and press enter. Next, open Google Colab. You need to upload the ipynb file here. Select the ipynb file and drag and drop it here. Now it is uploading to Google Colab. Now it has been successfully uploaded. Now Google Colab is opening. Now it has been successfully uploaded. Next, I'm going to give some information about Google Colab. Google Colab Notebook is a code development platform created by Google. It is open source, cloud-based, and most Python libraries are pre-installed, so we can simply import and use them for our purposes. Additionally, the GPU is free for up to 6 hours. After that, it will be disconnected, and it is mostly used to train machine learning and deep learning models. And that's a brief overview of the Google Colab Notebook. Next, we are going to look at the code explanation for the project. First, you need to mount Google Drive in order to store files in Google Drive and access files from Google Drive, which is especially useful for saving your work and keeping your data safe. If we store our data in this Colab notebook, once the notebook is disconnected, all the data will be deleted because it is only stored temporarily in RAM, which is cleared when the session ends. So RAM only stores data temporarily. So once the notebook is disconnected, all the data will be deleted. That is the main reason for storing our data in Google Drive, for safekeeping and easy access. This is a library for mounting Google Drive on a Google Colab notebook. Then, using Drive mount, we will download the dataset using a Kaggle API key. Kaggle is an open source platform that contains a lot of machine learning and deep learning datasets. The PPE dataset is also available on the Kaggle website. First, import files from Google Colab, which makes it easy to upload your files to this Google Colab notebook. Then LSS is a command used to access your Kaggle JSON API key. Next, install Kaggle. Then create a directory named .kaggle. Then copy Kaggle JSON and it will be moved into the .kaggle directory. Pre-WD stands for present working directory, which is used to get the current directory. Then set the file permissions for Kaggle JSON using chmod 600. This is the command to download a dataset on Google Colab notebook. Kaggle is a command used to download datasets using the API key. Datasets download the, and this is the dataset name PPE dataset. The dataset size is 669 MB and this is a zip file which will be unzipped to extract the dataset. After that it will be stored as a folder, and then comes Dataset Visualization. This is a random visualization of the dataset in the training images. This is a function to display images for which we need to provide some arguments. The arguments are image paths, title, column set to 5, number of images is 25, and then once we call this function, it first shuffles the dataset, then gets the minimum number of images in the dataset. Rows are 5 and columns are 5. The figure size is 12 by 12, and then there is a subtitle. And iterate over the image paths using enumerate and a for loop with ELT subplot to plot a subplot image here. Then open the image, which is to display an image. Then set the title, turn the axis off, and finally visualize all 25 images. Rows are 5 and columns are 5. Next we will see how to train a model using Ultralytics with the YOLOv8 model. I'm going to give a brief introduction about YOLOv8, which stands for You Only Look Once, and this is version 8. Previously, there have been many versions available of the YOLO algorithm, such as YOLOv2, V3, V4, V5, V6, V7, V8, V9, V10, and V11. Specifically, we are going to use the YOLOv8 model because its accuracy has been improved. The number of model parameters has been reduced compared to the existing YOLOv7. It achieves better MAP and it reaches a lower minimum loss value in this YOLOv8 algorithm. And this algorithm is especially used for object detection, object classification, and object segmentation in an image or frame. This algorithm is based on a working convolutional neural network which contains up to 53 convolutional layers and features cross-stage partial connections within the network. These connections help transfer features across different layers in the YOLOv8 algorithm, leading up to the final layer, which uses a linear activation function to produce the output of the layer. The outputs include bounding box coordinate data such as xon, yone, x2, y2, as well as the class name and class code. Now let us see how to train the model. First, you need to connect the Google Notebook to a T4 GPU. Now it is connecting. Then open the files. Make sure that it is connected to the T4 GPU. Now it is connected to the T4 GPU in the runtime management section. Open the PPE IPyNB file, select GPU, and then you need to mount Google Drive. You simply need to connect to Google Drive. Then choose your account. Then continue. Then continue. Now it is mounting and Google Drive and the Google Colab notebook have been successfully mounted. Next I'm going to show you how to get a Kaggle API key. First you need to go to Google and type Kaggle here. Then press enter. You must sign in. Then you need to go to this logo. Then you need to go to settings. Then scroll down. Then create a new token. Continue. Now it has been successfully downloaded. You need to go to the notebook, then run this cell. Then choose the files. Then open them. Now the file is uploading and it has been successfully uploaded. You need to run this command to download the dataset from Kaggle. The dataset size is 69 MB. Now the dataset has been successfully unzipped with the folder name PPE dataset. Next, I'm going to execute this cell. Next, I'm going to execute this cell for dataset visualization, which will display up to 25 images from the train folder. There are 5 rows and 5 columns for a total of up to 25 images. These are the dataset images. Next, I'm going to look at the model training code execution. You need to install Ultralytics, then import Ultralytics YOLO. Now Ultralytics has been successfully installed. Next, I'm going to install the pre-trained weight PT model, which was trained on up to 80 YOLO classes. These are the initial weights which will be loaded into the YOLOv8 model. Now YOLOv8 has been downloaded. Then I'm going to run up to 250 epochs with image sizes of 698, and the model weights will be saved in the PPE folder on Google Drive. This is the dataset YAML file. We need to make changes here. Set the train images path to content, PPE dataset train images, and the validation images path to content, PPE dataset valid images. Next, I'm going to run this cell to start model training. After that, you need to close it. This is a convolutional layer from the YOLOv8 neural network architecture. Here is a summary of the model, 225 layers. The total number of parameters is 8.2 GFLOPS. Now model training has started successfully. The first report is now currently running and in progress. This shows the GPU memory usage, bounding box losses, classification losses, DFL loss, and the number of instances. The image size is 698. Now the first 2 epochs have been completed. Now the first 2 epochs have finished successfully and the third epoch has started. We have achieved a map at 0.5 of 0.6 and a map at 0.5, 0.95 of 0.32. Recall is 58 and precision is 55. We need to wait until the model training is finished. Once the model is trained, we will be able to perform inference using this trained model in the VS Code platform. The model training has been successfully completed for up to 50 epochs. The overall map achieved is 81% and the MAP at 0.5, 0.95 is 54%. This shows the individual class precision. Recall, map at 0.5 and map at 0.5, 0.95. And here are the precision and recall values. Here precision refers to the proportion of correctly identified positive cases out of all predicted positive cases. The formula is true positives divided by the sum of true positives and false positives. Recall refers to the proportion of correctly identified positive cases out of all actual positive cases. Next, I'm going to show the weights of the model file. First, you need to open Google Drive, then go to My Drive. Next, open the PPE2 folder. Then open the weights folder, which contains 2 files, best, PT and loss, PT as well as phone, curve, PNG, precision, recall, curve, PNG, precision, curve, confusion, matrix, labels, results, and train batch images. You need to download these model weights for model inference on the VS Code platform. In the next step, we will see how to perform inference using this trainer-based PT model on the VS Code platform. Now download it. Once the model training is successfully completed, they need to obtain the model weights from Google Drive. They need to place them in this folder and it must be present in the PPE deduction folder. Next, we will look at the explanation of the inference code as it is executed in the VS Code platform. Next, I'm going to open this folder in the VS Code platform. First, you need to replace it with your CMD. Then type old space dot here and it will redirect you into VS Code. Now it has successfully opened. The project folder is named PPE deduction. First, we need to import a necessary library for making inferences in the Steiner model. The libraries are regular expression, which is used to remove some unwanted text in the sentence. JSON file, which is used to store data in JSON file format such as key and value pairs. And then import Flask, including Flask app and render. Template, which are used to load HTML code from the templates folder, to handle requests, and to return responses. Data as JSONify format, which is used to convert data into JSON format for responses. Redirect for redirecting to URL. URL for generating URLs for specific sections, which is used to get the response. And request for handling incoming requests. Then import CORS from Flask CORS, which is used to prevent CORS policy errors. Then CV2, the OpenCV library, which is used for handling image processing. Then CSRF protection, which is used for security against CSRF attacks. Then NumPy, which is used to handle arrays of data. Ultra library, which is used to make inferences using the trained model. CV zone, which is used to draw text in an OpenCV window. Then import SQLite, which is used to store user data such as username, password, and first name. Then sort, which is used to assign a unique object ID to each detected object. Ast, request, base64 data, and threading, which are used to access shared resources. Then initialize the Flask framework. Then create an object for Flask, which is assigned to the variable app, and it is used to prevent CORS policy errors. Then a secret key for this app was successfully created as GAY, and contact data JSON is used to store contact information in this JSON file. Then the initialization of the NVIDIA Nim API. And here is the NVIDIA Nim, a platform used to deploy large language models. If we are able to provide input to the large language model, we can then get output responses using this NVIDIA NIM API, which includes many LLM models such as FloresNet2, Pi 3.5, LLama, DeepSeek, Mistral, and others. These are the models available on this NVIDIA platform. With the help of the NVIDIA Nim API URL, we will send a request to the Pi 3.5 Vision Instruct model and then receive a response indicating whether there is a person in the image, whether the person is wearing a hard hat, whether the person is wearing a mask, and whether the person is wearing shoes. This is the information we are going to obtain using the NVIDIA Nim API URL. And Pi 3.5 is a large language model, specifically a multimodal model that was first developed by Microsoft. In the NVIDIA Nim API, it is free for up to 10 API calls if you have a Gmail account. After that, charges will apply based on the number of API calls, and the Steam is set to false. Next, initialize the Flask API. The API endpoint is with the methods get and post. Get is used to retrieve a response, and post is used to send a response to this specific API. This is a project function. Then render template is used to load index.html. Next, initialize the second API. Its name is hero, which is the home page, and it is used to load index.html with the help of render template. Then the model inference API is defined. Render template is used to load model HTML, followed by the login page API, and then the register API. Request method is used to get the method name when specified in the Flask web browser. If it is post, then proceed to the next step. SQLite is defined in the code above. Then connect to a database. The database name is project database DB. Then connect a cursor. C execute is used to drop any existing user credentials and create a table with columns for first name, last name, email, and password. Request is a function used to receive a request from the web browser. with the data format being form. Then get is used to access the first name, last name, email and password. Next, C, execute will store this data in the created SQL database with the column names, first name, last name, email and password. Commit will save the changes. The message registration successful is returned with status successes. If there is any error, it will go into the except block search. As if the email already exists, then the status is set accordingly and the connection is closed. If registration is successful, it will redirect to the login page with a message and status successful. If not successful, it will remain on the same page, register HTML. The next API is the About API, which contains information about PPE detection. The Submit contact API is used to submit name, email and message, and this message will be sent to the management of PPE detection. The contact entry name, email and message is used to load an existing JSON file. If it is not available, then a new one is created with an empty list. Then the data will be appended to the JSON file, and finally the JSON file is dumped. Then a response is returned with status success and the message contact details saved successfully with response code 200. The next API is the login API, which is used for logging into the web page. First, connect to SQLite with the database, create a cursor, then get the first name and password, then execute to check with the existing details. Once it is successful, commit and close the connection. If the flag is 1, then it will be redirected to the model HTML page. If it is not successful, it will remain on the same page with the message invalid credentials. Please try again. These are the file formats that will be permitted during model inference as specified in the set data type. For image extensions, the allowed file formats are PNG, JPG, JPEG and BMP, while for video files, the formats are MP4, AVI, MOV and MKV. Allowed file is a function used to check whether the given input file belongs to the image extensions or video extensions. The file name refers to the image path or video path. It accesses the part after the dot, converts it to lowercase, checks if it is present in the allowed extensions, then returns a response and proceeds with further execution. Then initialize the output frame, which is initially set to none. Once the model inference has started successfully, the output frame will be assigned to this variable. Next, initialize threading, log, then initialize the predict API with the host and target methods. After that, access the output frame variable inside the predict function using the global keyword. If the file is not present in the request files, then return file is required. If the file is available, then access the file using the request function. If file name is empty, it means no file has been selected. So this error will be displayed on the Flask model inference page. Then convert the file name to lowercase and print your file name. Next, convert the image to base64 format. Base64 format is a string data format that contains a lot of text data in base64. You need to provide the image path for this. Then read it in binary format. Next, convert to base64, base64 encode, then read the file and then decode it. Then initialize the headers, which you will need in these headers: NVIDIA Nim API key, authorization, and then accept only certain important text if the stream is either true or false, which will be present in the application JSON format. And we have written a custom prompt for the Pi 3.5 vision instruct model. Analyze the image and fill in the JSON format. In the JSON format, make sure to thoroughly check if anything is not visible. It should specify what is not visible. For example, if something is visible in the image and the payload, which includes the model Microsoft Pi 3.5, vision, instruct model message, role, user, content, prompt and image, which is in base64 format. These are the hyperparameters. Max tokens is 512, temperature is 0.2, top is 0.7, and stream can be true or false. We have set it to false, which makes it easy to send a response using the post method. Invoke, URL, and headers. This is the payload data. The model output will be received in the variable called response. If stream is false, then the else condition will be executed. Then response JSON will be stored in the data variable. Next, check if choices are available in the data and if the length of data is greater than 0. Then access choices, message, store it in the message variable, and then access content from the message variable. If content is available and it starts with the JSON format, then strip it, which means to load the data in JSON file format, then print the detected elements and PPE data here, and then the PPE data will be displayed in the Flask web browser. If it is not, decode the data, JSON decode error. If the content is empty, it means the API response structure was unexpected. This is the else condition. If the user provides an input video file, then this condition will be satisfied using the allowed file function. Then join the path for the PPE video, which means saving the file path and printing the video path. If the video path does not exist in the folder, the video upload fails with a 400 error. CV2 video capture is a function used to provide the video file path to this function, and then it is used to extract frames using this video capture function. Then cap is an object used to read a frame from the video. Then sort is a technique used to assign a unique ID to each detected object. Next, max age is a parameter set to 30, which is used to load class names such as hard hat, mask, person, and safety vest. YOLO is a function used to load the trained model weights. The model file path is best PT. Then it will be stored in the model variable. The while true loop keeps running until there are no more frames. Then cap ready reads frames from the video, and the frame is stored in the frame variable, which can be either true or false. If a frame is available, then it is true. If a frame is not available, then it is false. If a frame is not available, then stop the execution. Detection is a variable used to store the bounding box coordinates such as zone, y1, x2, y2, and a confidence score. In the model function, we need to provide the input frame to the model, then obtain the output of the bounding box coordinates for the detected object, the confidence score, and the class name. Then iterate through the results using a for loop, retrieve the boxes from the information, and then iterate through the bounding box information such as the bounding box coordinates, confidence score, and class index. Next, access the bounding box coordinates from box xy, which gives x1, y1, x2, y2. Then access the confidence score from the box and access the class index, which contains only an integer value. Then convert it to a label using list indexing. We are going to process the output data here. If only a person is present in your frame, then store the detection information in the variable called detections. Then draw a rectangle for the remaining objects using the bounding box coordinates and the frame. Display text in the OpenCV window, and then provide the positive detection information to the tracker, which is used to assign a unique ID to each detected object. Then iterate through the tracker results, retrieve the object ID using this tracking method, and then convert it into an integer. CV2. Rectangle is a function used to draw a rectangle around the detected object. Then CV2 put text is used to display the person ID in the OpenCV window, specifying the thickness and where the text should appear in the OpenCV window. This part sets the color to white. and this one sets the scale. CV2 I'm sure is a function used to display the output frame in an OpenCV window, but here we are just commenting it out. Instead, we will display the output frame in a Flask web browser, including the bounding box and PPE information. Then with the log, this condition is used to store the output frame variable here. Next, CV2. Wait key is a function used to stop the execution with the help of the Q prime key. When we press Q, the program execution will stop and break out of the loop. Once all the frames have been processed, it will return to the web browser with the video path and data to. If the input video file path is of an invalid file type, a 400 response will be sent to the Flask web browser. Generate is a function used to encode the image using the CV2 ImEncode method. First, the output frame is accessed under the log variable using a global variable, and while true, the loop keeps running until the frame becomes empty. If the log condition is satisfied, it will then check if the output frame is none. If so, it continues. Next, it prints the output frame's shape and then encodes the output frame. The encoded image will be stored in the encode image variable. Flag is either true or false. If not flag, then continue further. While is a condition used to convert the encoded image into byte array format. This is a video feed API which is used to send your response to the Flask web browser and then display the output frame in the video feed API web browser. This is the main function. The program execution starts from this function. This is where the Flask app runs. Debug is set to true. When you change anything in the code, it will automatically be saved. Host is used to get the IP address of the machine. Port is 50, which means your application is running on port 50. Finally, we are going to see the code execution of the project. For that, first you need to open the VS Code terminal and open a new terminal. First, you need to install the necessary libraries for the code execution of the project. And then you need to type here pip install r requirements.txt, then press enter. Now the packages are installing and now they have been successfully installed. Next, I'm going to show you how to get an NVIDIA Nim API key. For that, you need to go to Google, then type NVIDIA Nim here. Then press enter. If you haven't signed up for NVIDIA Nim yet, you will need to sign up first and then log in. I've already signed up. Now I'm going to log in with my email ID and click next. Then it will redirect you to your Gmail. Next, you need to go to Python, get the API key, generate the API key, and then paste it. Then you need to paste this NVIDIA Nim API key into the designated field and then click next. Finally, I'm going to execute the inference py file. For that, first we need to get this file. Copy the relative path, then paste it here after by and press enter. Now Flask has successfully started running with the IP address 10.147.21.13 and the port is 50. This is the HTTP URL. Then you need to get this IP address, copy it, go to Google, paste it here and press enter. This is the home page. About us, login, register, contact. About us. This section is about PPE detection information, what makes it special, how it works, and why choose AI powered PPE detection. Join us in enhancing workplace safety. Then go back again to the home page. Next, I'm going to register first and then I'll enter my personal information. My first name is and my last name is. Then I'll enter my email ID here, create a new password and then create the account. After that, it will redirect to the login page where I'll enter my name and then enter the password here. Now it has successfully redirected to the model inference page. First, I'm going to upload an input image to the NVIDIA Nim API, and then I'll receive a response. First, we need to choose a file. Then we need to go to PPE detection, PPE image. First, I'm going to upload PPE 1 JPEG, then select it, then open it, and then submit and predict. This is the output provided by the NVIDIA Nim API model. Wearing gloves? No. Wearing goggles? No. Wearing helmet? Yes. Wearing mask? Yes. Wearing shoes? No. Wearing vest? Yes. Then I'm going to provide another input image. Then open it. Then submit. These are the prediction results. Wearing gloves? Yes. Wearing goggles? No. Wearing helmet? Yes. Wearing mask? Yes. Wearing shoes? No. Wearing vest? Yes. Next, I'm going to use a video file as input. First, you need to choose the input video file. You need to go to the PPE detection folder. Then go to PPE video. I'm going to choose PPE input video 1 MP4. Then you need to open it. Before submitting and predicting, get this URL, then paste it into another tab and type here video feed API. Press enter. Then you need to submit and predict. Now the inference has started successfully, predicting the person with a bounding box, hard hat, safety vest, and person, which is being inferred in VS Code, and now it has completed successfully. Then I'm going to provide another input video. For that, first you need to choose a video file. So I'm selecting PPE input video 3 MP4. Then submit and predict. Now the frame has been successfully updated here. The person is wearing a safety vest, mask, hard hat, and safety vest. Now it is predicting the mask as it processes a frame. Now all the frames have been successfully processed. Then I'm going to provide another input video. Select the file pp input video to MP4. Submit and predict. Now it's currently processing the third video in the sequence, and the model inference process has started successfully, accurately detecting safety vest, hard hat, and person. The inference is now running smoothly within VS Code as expected. The frames are being processed continuously. The frames keep updating. Now all the frames have been successfully processed. Next, I'm going to stop the execution with Ctrl C. I hope you understood everything from my explanation of the project and the code. If you have any questions about the project or the code execution, please share your thoughts in the comment section. I'm ready to help you. Thank you.
Hope you enjoyed the course. Course will surely give you solid foundation in computer vision, and then it will help you on your final year projects also, and then surely it will help on your cracking your job interviews. While implementing this project, if you face any kind of difficulty while implementing the project or while setting up an environment, or if you get any kind of doubt, you can feel free to put in the comment section. We will surely help you in as soon as possible in a better way. Thank you.